Imagine yourself at the beginning of time, the beginning of everything that exists and ever existed. Watch the universe you call home in its nascent state, being born, creating with itself space, time, and the intricate properties these hold. Watch the atom that make you up and
Fatima, don't bore them.
oh, okay. Then let's just do it your way. So Vaishnavi, what are your like 3 a.m. random thoughts?
Well, mainly just Hershey bars, Bloody Mary, and why RCB still hasn't won yet.
That's so mature of you. Well, I think of more important stuff. Like
Like, why hasn't he texted you back?
no, come on, like more important questions, like where it all came from, how you and how everything in this universe came to be.
Well, sure, genius. Who hasn't thought of that?
But did you think of it well enough to understand it? Hello, dear listener, I'm Fatima,
And this is Vaishnavi, and you are listening to Solving for X.
where we dive into any X willing to be explored, explained, and understood. In this episode, we will explore a rather fundamental question that is challenging not just you, not just your grandfather, or my goldfish Becky, but also many scientists and philosophers like Ptolemy, Aristotle, and Einstein.
And of course, me too. Well, the answers to the hows and the whys came through various sources. In the route we take, we will explore how these ideas even came to be. One of the first explanations came through religion, or religions, I should say. Like almost every other question that science had not developed enough to answer, religion stood as a reliable source to answer these.
The Abrahamic religions in common tend to hold the view that the earth and the heavens had been created by a god. This God is not bound by space, time, or even physics, and He created the world and the earth and heavens in 6 days. Some take the 6 days to be literal, while others take it in a symbolic way. Quoting the verse from Genesis chapter 1, verse 3, in the beginning God created heaven and the earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. And God said, let there be light, and there was light.
At the same time, Hinduism presented a slightly different answer. From a void, a cosmic egg called Brahmand appeared. Inside, Brahma, the creator, hatched and shaped the universe. Sometimes Brahma arises from a lotus linked to a Vishnu. This creation is a part of cycle with Vishnu the preserver and Shiva the destroyer and transformer.
Some view see creation as the interplay of consciousness and matter. Ancient themes often speak of a cosmic being's sacrifice resulting in the formation of reality.
Meanwhile, in Greek mythology, everything begins in a chaos, an empty, formless void. From that, Gaia, as in the earth, and Uranus, as in the sky, are born. And together they give rise to the Titans and eventually the Olympian gods, who mold the world as we know it.
Across the globe in ancient China, the story begins with Pangu, a primordial being who hatches from a cosmic egg. As he grows, he pushes the heavens and the earth apart, creating the sky and the land. When he dies, his body becomes the mountains, the rivers, the sun, and the moon. Everything in the natural world.
And in Egyptian mythology, the universe was said to emerge from a vast chaotic ocean called Nun. Out of this darkness, the god Autumn, or sometimes Ra, arose and willed the world into being, crafting land, sky, and life itself.
Each of these myths is rich and symbolic. They reflect not just imagination, they also reflect the deep philosophical and cultural ideas that were crafted long before even the language of physics was born.
Of course, physics. And maybe that is why these two very interesting mythologies don't usually add up to what we can observe.
Observations. We know who have a knack for that. The science guys.
And girls,
Of course, of course. girls too. So came physics and physicists and well philosophers. They entered the picture and brought with them revolutionary thinking that would change the way everyone else would ever see the world.
But they weren't always right either. For nearly 1400 years, people believed that the Earth was the center of the universe, with planets and stars moving in complex circular paths called epicycles around them.
1400 years is a long time. This model was called the geocentric universe. It was mainly credited to Claudius Ptolemy of the 2nd century CE. It is an example how people have always thought of them to be special or to be central to everything that ever happens. It greatly aligns with the religious sentiments of the time too.
Since this model mainly fits in with what people could see, like the sun rising and then setting, as if it were moving around the Earth, it also gives space for heaven and hell beyond all the planets and stars they knew about. Finally, with the growing ideas in Asia and Islamic Golden Age, with mainly Aryabhata, Ibn Sina, Al-Tusi, with ideas like Earth rotating on its axis, the perspective changed from the geocentric to the heliocentric model, where the sun is the center of the universe. And much later, this changed to just the center of just our little solar system, one of the many in our own Milky Way galaxy. Again, one of the many galaxies in a rather wide universe.
But how does any of this matter to how the universe began?
To know the beginning, one must analyze the present and understand the past. One way of doing this is to understand what has changed since the oldest times we can look into and then the so called now.
At a time when most scientists believed the universe was eternal and unchanging, an astronomer entered the picture. Edwin Hubble was his name. He shattered that view forever. While peering into the skies through the Mount Wilson telescope, he noticed something astonishing. The galaxies, the immense glowing cities of stars, they weren't just scattered randomly, they were actually moving away from us.
And not just moving away like casually neighbors avoiding small talk. The galaxies that were further away were speeding at much faster rates. It was like space itself was stretching, pulling everything apart. That's not what you would expect from a universe that's supposed to be calm, still, and eternal. Something big was going on, literally, like not expected.
This is now known as the Hubble's law. This literally shook the world and it sparked a revolutionary idea. If everything is spreading apart, and at some point in the past, everything must have been packed tightly together, like really tightly. Like all the matter, energy, space, and even time itself compressed into a
S-
single, impossibly hot and dense speck.
This is how, ladies and gentlemen, a seed was planted. A seed to the biggest and most life changing, or should I say, life forming idea ever. The Big Bang Theory, as we know it today, came to be. But here's the twist: it wasn't even Hubble who came up with it first. It was fascinating Sir George Lemaitre.
I bet many of you are hearing the name for the first time. In fact, this Belgian man, who was a man of both faith and science, yes, Georges Lemaitre, was a physicist and a priest. He proposed that the universe started from a single, primeval atom. He imagined the cosmos beginning in a kind of cosmic egg that burst apart into a mighty expansion. Not really like a bang or a push or like fireworks, but more like the stretching of space itself. Of course, people back then were like, a priest talking about the universe birth? That's just religious philosophy in a lab coat. But here's the thing, his math was solid and his physics was legit. And he even beat others to the punch by using Einstein's theory of general relativity to back himself up.
Speaking of Einstein, he hated this idea at first. He wasn't really a fan of it. He, who had noticed his equations show that the universe would have been expanding, actually tweaked his equations to force the universe to remain static, adding a term known as the cosmological constant to make the math add up. Because even he thought the universe had to be eternal and unchanging.
But then, boom, Hubble's observations came in, and Einstein took one long look at it, and the expanding universe suddenly made sense. He basically went, damn. He even called adding the constant the biggest blunder of his life. It's kind of dramatic, but also kind of epic.
Still, even with Lemaitre's maths and Hubble's galaxies, some scientists were really full convinced. I mean, you are telling them the universe just exploded into existence from a point? Sounds wild, right? That's when the universe decided to leave behind a little receipt, a signature of that colossal beginning, the cosmic microwave background radiation, the literal afterglow of the Big Bang.
Okay, so this part is kind of hilarious. In 1965, two engineers, Arno Penzias and Robert Wilson, they were fiddling with a giant antenna at the Bell's lab. They kept picking up this weird, persistent hiss from space. No matter where they pointed the dish, the sound wouldn't go away.
At first, they thought it was interference or maybe pigeon poop on the equipment. Seriously, like they actually cleaned bird droppings from the antenna, hoping it would stop the noise. But the hiss stayed.
Turns out they had stumbled upon just one of the biggest discoveries ever in cosmology, and without even meaning to. That static hiss was actually radiation from the early universe, cooled down over billions of years. It was the leftover heat from the Big Bang, still echoing through the cosmos.
Turns out it's a universe saying, "Hey, I'm still here."
And that was the moment the Big Bang Theory gained its massive credibility. The static hiss, that little sound, that was the past whispering proof to the present.
So, wait, if the radiation is everywhere, is it in this room right now? And if it is leftover heat, why aren't we all melting?
That's a good question. It's not hot anymore. That's why we aren't melting. So, see, around 380,000 years after the Big Bang, the universe finally cooled down. It cooled down enough to form atoms. Before that, it was this chaotic soup of particles and light that couldn't travel freely. But the moment atoms formed, light was suddenly free to roam. And absolutely, you are literally bathing in 13.8 billion year old radiation. But don't worry, it's harmless and very, very cool.
This, in a way, is a baby picture of the universe and is very important to us. In fact, the cosmic microwave background radiation is strong evidence for the expanding universe because we can detect this faint radiation uniformly spread across, even in regions of the universe that seem too far apart to have ever communicated with each other, unless they were once incredibly close together in a hotter, denser state.
Also, one needs to get clear, one needs to understand what expanding really means here.
Isn't that obvious? I mean, the galaxies and the stars and all the celestial bodies are moving away from each other, right?
I mean, that's what one would think, but here's the thing. Your brain might start doing cartwheels. If everything is moving away from everything, does that mean we are at the center of the universe? Because we see it that way? Okay, to clear this cartwheel situation, picture this. A universe is like a loaf of raisin bread. It's raisin bread dough rising in the oven. The dough itself is space, and the raisins are galaxies. As the dough rises, each raisin sees the other raisin moving away from it. Not because the raisins are moving away, it's because the dough is expanding between them. It's not the raisins that are moving away from each other.
Huh? Okay, so hold on. So it is not the galaxies moving away from each other, rather the fabric of space itself.
Yeah, spot on. No reason is the center because it's the door, which is the fabric of space itself, that's expanding. So when we look around and see all the galaxies zooming away, it's not that Earth is special. It's just that space is stretching everywhere, all at once.
And the further away a horizon is from other, the more dot there is between them, and the faster they seem to move apart. That's literally what Hubble said. The Hubble's law. It's like the universe is baking without the delicious smell, I guess.
Or the
To
carbs. Yeah. So basically, we are all just raisins in a giant cosmic oven, slightly burned and completely in awe.
and now I'm hungry too. Wait, we talked about how we think the universe began and what's it doing now. That is expanding. So what next?
But we still have a lot to talk about, right?
Look,
So,
no. I mean, what happens to the universe next? Does it keep
oh,
expanding or
no. So this is like finishing your favorite Netflix series, and there is no season two, and it's on a cliffhanger. Or is there a season two?
but I need closure.
Yeah, and so does the universe. So there are a few fascinating and very depressing theories about this. And they are all, let's just say, dramatic.
One idea is the big freeze, which is honestly as cold and depressing as it sounds. The universe keeps expanding forever. Stars burn out, galaxies drift apart, temperatures drop so low that even atoms can't move. They just freeze, as for the name.
Mm. So, like an eternal winter, but no hot chocolate.
Exactly. But I'm hungry, so don't. Okay. It's driven by something we still don't fully understand called dark energy. It's like the mysterious villain who no one asks for but controls literally everyone.
Ooh, okay. True that though.
Dark energy is this unknown force that's pushing the universe to expand faster and faster. We don't know what it is, but we know it makes up the 70% of universe. At least 70% of everything that exists is not even understood properly.
Or maybe the universe will end in the big crunch way. It's where the gravity pulls everything back, like a reverse Big Bang. Or the wildest one, I love this, the Big Rip, where space expands so fast it literally tears galaxies, stars, planets, and eventually atoms apart.
And even that is in the end of the mind bending theories. Some suggest the universe might just cycle through expansions and contractions in an endless loop. Or maybe it gives birth to other universes. A cosmic multiverse bakery, if you will. It makes me more hungry,
Everything's gonna make you hungry.
I
Okay,
guess.
yeah. But there's something I still don't get. If energy cannot be created or destroyed, and we say the universe is expanding, heating, cooling, evolving, where's all this energy coming from? How do they do this all?
Okay, here comes the ultimate shocker, the ultimate twist. The universe's total energy might as well as be zero.
What? Wait, actually? Okay.
Yeah, it turns out that the galaxies the energy in matter, galaxies, stars, you, me, everything is positive. Okay, like a positive symbol.
Oh,
But the gravitation energy that holds everything together, that is negative.
oh. So it's like the universe is perfectly balanced, as all things should be. Thanos would be proud. Okay. Yeah.
It also kind of solves the mystery of how something came from nothing. If the total energy is zero, the universe didn't need to break any rules by existing.
So you're saying we might all be the result of a very lucky accounting trick?
Pretty much. A quantum fluctuation in the vacuum that netted out to zero, and yet here we are, doing a podcast in a universe that's technically free.
Now that's cosmic capitalism.
From cosmic X and divine creators to raisins in ever expanding dough and energy accounting tricks.
We began with myths, moved through telescopes, laws, and some accidental discoveries involving pigeon poop, only to find out the universe might just be the most poetic accident ever.
Or the most intentional fluke. Either way, it's really comforting, isn't it? That
Mm.
even in the vast silence of space, we found a voice, our own.
As Carl Sagan said, the cosmos is within us. We are made of star stuff. We are a way for the universe to find itself.
Thanks for tuning in for this episode of Solving for X, a humble attempt to understanding the world at different times and different ages.
With different perspectives and exploring things that make everything and everything that exists within and beyond it.
This is Vaishnavi.
This is Fatima.
Signing off.
If you stay till the end, you definitely deserve a treat. So we suggest you to check out Mankind, the story of all of us. It's a documentary on Prime Video and offers deeper insight and, of course, existential crisis. And if you're looking for something that's hilarious while exploring science and the wonders of this world, check out Kunk on Life. It's an outstanding mockumentary on Netflix. And for more such episodes, tune in. We are here for you every Saturday.